Welcome! In this series of short videos, we will look at topics for the PowerBasic Windows compiler. Today, we will look at determining screen metrics. We're going to be using the Windows compiler today because much of the code we're going to be looking at is to do with the size of screens. When you're writing an application, your application may make full use of the screen. However, there are some applications you may write in the future that may want to make use of multiple screens if the user's system does actually possess more than a single screen. This is what we're going to look at today. PowerBasic does come with some basic metrics that allow you to see how big screens are. There is a metrics command. Now the metrics command has a number of options in the help file, which we'll have a quick look at. Calling the metrics command with a parameter allows you to pull back information on the sizes of various aspects of screens. Dialogues, menu bars, icons, frames, etc. The one we're going to be using initially is the maximized. This will tell you the width of a screen once maximized as a top level window. Also, it will tell you the height of a maximized top level window, which basically tells you how big your screen is. So we'll just push this out to the log, and since the metrics command will return a number, we're going to change this into a string so we can display it in our log. Now we do exactly the same for the height, and if we run our code now, we'll see that what we're getting back is 1936 by 1056. Now, how does that relate to the size of the screen we're actually working on? If we right click on a screen and look at display settings, we'll see that we have 3 monitors on this one, and the one we're currently running on is running at 1920 by 1080. Now the size we got for the width is slightly larger than that in the width and slightly lower than that in the height. There are other commands you can use to pull back the size of the desktop. Let's try those and see how they compare. Now what we're doing now is we're using the desktop get size command to send the size to a width and a height and display this on the screen. So let's try that. Now this one is quite correctly returning 1920 by 1080. So we can see there's a difference in sizes here. The width is slightly wider and the height is slightly smaller. Now there are things on the screen which you can't really afford to make any assumptions about. At the moment we have the taskbar at the bottom of the screen. Most people normally run the taskbar down here, but there's nothing to stop a user holding down the left mouse button and dragging the taskbar over to the right hand side of the screen. And if we run the same code again, we'll see that while the desktop size is still exactly the same, the metrics commands have returned 1843 width by 1096. Now the 1096 has gone up because we're no longer using any space at the bottom of the screen, but the width has gone down. We've actually used up the space on the right hand side where the taskbar is now. Knowing the size of the usable area on the screen is very useful for a developer. Your application may have a minimum size at which it will work properly. And if the user is actually using a screen that has a resolution much smaller than your minimum size, you may want to check this at the beginning of your code's execution to make sure that your application will run properly on the screen. If the user is using a screen resolution that is too low for your application to work properly, you can warn the user of this right at the beginning of your application and stop the application from working. So what other commands have we got? Well, we used the desktop get size. There is also a desktop get client. If we run that one to do exactly the same task, sending it to long width and long height, we'll see that this is returning a width of 1827 by 1080. So it is giving us a reduced number for the width because it's taking into account the fact that the taskbar is over here on the right. If we move the taskbar back down to the bottom of the screen again and run our code again, we'll see that this is now returning 1920 width, so full width, but a reduced height, so 40 pixels less than height, which is what's used to take up the taskbar. So there's always a possibility that the user won't have the taskbar where you expect. Another command, which is useful to get the information from, is the desktop get location. This again is going to return an X and Y coordinate size. If we try running this now, we'll see that it's returning 0, 0. That's because the top left hand corner of the screen which we're currently on has coordinates 0, 0. As you will see from the help, the desktop client area is the part of the screen that's not obscured by the system tree. Now while it's 0, 0 at the moment, if we move the system tree over to the left hand side of the screen, we'll see that our figures are going to be different. So there is our system tree taskbar over on the left hand side. If we try running that now, we will see that the X coordinate is now 93. So the client area now starts 93 pixels in from the side. Useful to know if your application is going to display a dialog or an object on the screen underneath where the taskbar would actually be. Now, as we've seen from this program so far, there are actually 3 monitors on this computer. The code we're going to do now is going to actually check to see how many monitors, because while you may know how many monitors are on your own personal computer, if you're actually issuing applications to other users, you will have no idea how many monitors they actually have. And you may want to actually write applications which make use of more than one monitor. So to help with this, I've included a new library, pbmonitor.include. Now there are a number of routines within this library, which we will bring up on the screen here, which are quite useful. The first one we're going to do is we're going to check to see if there are multiple monitors. This is a test you can do at the beginning of your application to see whether it's worth actually working out if the user wishes to use more than one monitor. So we'll prep a local variable and we'll call the function to work out how many monitors the user actually has. And then we'll put a piece of code in which will tell us. So we're using 2 functions here, one to calculate the number of monitors and one to return a true or false if the user has more than one monitor. So if we run that code now, we'll see it does return that the fact the user does have multiple monitors and the number of monitors attached is 3. So if your application can make use of more than one monitor, perhaps displaying the primary information on the first monitor and additional information on the second monitor. However, if the user only has one monitor, then you can handle that in code. So, having determined that we have more than one monitor, can we display the details of each monitor? Well, if we prepare a long variable here, and we're going to go from 1 to the total number of monitors counted, which we had up here, and we're using the function monitor size, and we're returning the width and height of each of the monitors. So if we run that now, we'll see that we have 3 monitors attached. It counts on monitor 0. Monitor 0 is 920 by 1080. Monitor 1, the middle monitor, is 2560 by 1440. And the third and last monitor is also 1920 by 1080. Now the other thing to work out, if we look at the display settings on the computer, we'll see that the 3 monitors are actually in a row. Now there's no guarantee this is always going to be the case. It depends on the arrangement the user actually has. The number 2 monitor may be above the number 3 or it may be above the number 1. So can we work out the positioning of each of the monitors? Well, we can use the information stored in the global array to pull back that information. So the global array holds information on each of the monitors. And we're pulling out the first 2 bits of information, which are basically the top left-hand coordinate of that screen. So if we try running that, we'll see that the 0 monitor, the first monitor, starts at 0, 0. The number 1 monitor starts at 1920 by 0, and the third monitor starts at 4480 by 0. So the fact that the y coordinate is 0 for all of these, it's quite easy to see that the 3 monitors are in fact in a straight line. If one monitor was above the other, then the y coordinate would indeed be different. So if we moved one of the monitors, we can test that theory out. Let's take the number 2 monitor and we'll put it directly above the number 1 monitor. And if we go back to our code and run this now, we'll see here that the coordinates have actually changed. The first monitor is still at 0, 0. The number 1 monitor is 1920 by minus 36, so it's moved up slightly. And the number 2 monitor is almost aligned to the number 1 monitor, but it is considerably higher up. It's gone into the 1000 negative. So from this logic, you can quite easily see where all the monitors are actually set up in the system. And try applying that, and that should put them back the way they were. So now we've worked out where all the monitors are, can we do the same for dialogues? Can we work out which monitor the dialogue is actually on? Well, let's take a very simple dialogue. We'll just paste a new dialogue in. So this is a simple dialogue that's just going to basically have a button on it. And when we click on this button, we're going to return some information. So we'll put in the event handler, the callback function for this one. And all our callback function is going to do, when the button gets clicked, we're going to display a message box on screen, and we're going to call one of the new functions inside our PB monitor library, which is going to say which monitor this dialogue actually is sitting on. Right, and after we've displayed all our code, we want to make a call to show the dialogue. So we'll just put that in there. So there's a dialogue on screen. So if we click on the dialogue, it will bring a message box up to say it's on monitor 0, which is quite reasonable. It's the monitor we're actually on. So if we move this dialogue off screen onto the next monitor, and if I click the button there, and the message box that's brought up is to say it's on monitor number 1. Now if I move it all the way to the right and click on that one there, the message box, if we bring it back, is telling us we're on monitor number 2. So you can quite easily return the monitor number. Now this doesn't tie up with the Windows monitor number, because if we have a look at the Windows monitor number, we'll see that they are 1, 2, 3. I haven't found a way yet of actually tying these numbers together, but from our point of view it's fairly academic, because we know that monitor 0 is the leftmost monitor. Monitor 1 is the middle one, and monitor 2 is the one on the right hand side. And we can pull back the sizes of each of these monitors and where they are positioned in relation to the other monitors. So what we've done today are some basic screen metrics. We can work out how much of the screen real estate we can actually make use of. We can quite easily determine where the system tray and taskbar are actually sitting. And we can work out how many monitors the user has attached to the system and what the sizes of the screens on each of these monitors actually can cope with. The other thing that's worth mentioning before we go is when we showed this dialog on screen, we showed it with a dialog new pixels option. Now the option pixels is optional. If you leave this out, it will display the dialog in dialog units. Now there's a difference between the two. Pixels is obviously the number of pixels on the screen, and it's the physical location of your dialog on the screen. The idea behind dialog units is that it can display information and dialogues on your screen in a resolution independent manner. This is very useful if you're resizing dialogues or resizing controls on dialogues. If you want exact pixel perfect control of where your objects go on screen, say for example you're writing a graphics display or a game that needs the position on screen to be absolutely exact, then create your dialog with the pixels option. Should you need to convert between pixels and dialog units, there is a dialog units command which does the trick quite nicely. It can transfer units to pixels, and there's also a dialog pixels command which does the opposite. This way, if you need to actually convert one to the other, you have a means to do it. This has been a short introduction to screen metrics. That's it for today. Thank you for watching.